Hi, everybody. Thank you for joining the webcast today. We're going to give everybody just a few minutes to come on to line, so we'll start momentarily with the presentation, so just a few moments. Okay, let's go ahead and get started. So thank you for joining us for today's webinar on solving fraud and risk challenges. My name is Ron Wise. I'm an account manager at Webroot, where I manage the accounts of our financial institutions and then some of our technology partners. I'm very happy to be with you today. I'll be covering a number of different items related to machine learning. And it's my hope that the information presented today will really help you with analyzing and building your strategies for tackling fraud. And if you have any questions during the presentation, please feel free to ask via the BrightTALK app, and time permitting, I'll try to provide answers at the conclusion of the presentation. So let's go ahead and get started. First, let me go ahead and get through our agenda to give you an idea. We'll be doing an overview of artificial intelligence and machine learning. We'll explain why machine learning is critical. We'll try to cover machine learning-enabled solutions reduce fraud and how they help manage risk. How machine learning works, so we'll go step by step how that kind of works with an example, and then in the end we'll try to give you some ideas on how to approach vetting machine learning. So before we get into how artificial intelligence and machine learning are used, it's important that we understand really the differences in the terms. So many believe that AI and ML are one and the same, but if we take a look at their definitions, we can understand that although they are related, they're not really the same thing. So artificial intelligence, or AI for short, is when machines emulate human intelligence. So that's a pretty simplified explanation of what that is. Machine learning, or ML for short, is when machines sort through and analyze large quantities of data at a speed and volume that's really impossible for humans alone to accomplish. So one is leveraged to influence the other. So our next diagram will give us a better idea of how they are related. So here we see how the layers really work together. So the outer layer, or the AI part, is the most complex, in that all of it really has to do with intelligent interaction. So a good example of this would be driverless cars. We're starting to really see them being tested, and we're seeing a lot of them on the roads now. Also, recently, IBM's Watson, this is a great example of how artificial intelligence is being used. I understand recently it had a conversation with a human being, and then that conversation actually resulted in an argument, so that was quite interesting. The middle core, or the machine learning portion, is really the math part, so to speak. It uses algorithms to learn and improve without really being programmed to do so. And then finally, neural nets and deep learning. These areas help us with our machine learning models by taking general machine learning intelligence and making it more acute to human behavior. So cybersecurity is pretty labor intensive. We need to really research and identify the attacks, contain breaches, remediate the damage and restore the systems, and take steps to ensure that the vulnerabilities are then fixed. And humans are great at doing these on a small scale, and we can look for patterns, create rules, use heuristics, and find silver bullets. But the problem is that, we make mistakes and we suffer fatigue. Now machines, they don't do that. Machines are highly complex and they need to be trained, but they show no bias, they're scalable, they're highly accurate, and best of all, no coffee breaks or vacations needed. But humans and machines can work hand in hand to improve machine learning. So as an example, because we have humans constantly training machines to be more accurate, Webroot's machine learning model is able to publish millions of reputation updates every day on threats related to URLs, IPs, apps, and all kinds of different files. So the question may arise as to why we need machine learning. So why can't traditional means of security continue to be used to protect our environments? The answer: traditional security solutions, they just can't keep up. So the amount of attacks that we're seeing, they just continue to grow and grow and grow. So here's some numbers to consider. Overall attacks increased 200% from 2016 to 2017, and that percentage was surpassed in the first half of 2018. So we also saw a 60% increase in phishing attempts. That was also the first half of 2018, and 68% of phishing sites now use HTTPS to better impersonate those legitimate sites using HTTPS. So with the amount of attacks coming in on a daily basis, companies now face some major challenges. First of all, monetary losses, loss of reputation, and fines and penalties from regulatory agencies. Now, these are all things that could affect an organization's ability really to do business, and smaller companies are especially at risk of these types of challenges. So let's touch on financial institutions as targets. Financial institutions are always at risk for more targeted types of attacks because the bad guys, they know who has the money. But interestingly enough, if we look at the percentages of websites most impersonated by fraudsters, we see that tech websites are faked much more than financial institution sites. Now, why is that? Well, the answer lies in the amount of data that's available. Tech accounts such as Google are much easier targets, and there are far more of them. And financial institutions, they tend to use multi-layer authentication such as one-time passwords, and this makes stealing IDs and passwords much more difficult for the fraudsters. So the 2018 report by the Ponemon Institute broke down the costs incurred due to a breach. So specific to financial institutions, the average breach cost companies $206 per capita or per user. The churn or loss of customers was at 6.1%, and the overall loss of business averaged $4.2 million. Now these are U.S. numbers, but there is good news. Financial institutions are the fastest at identifying a breach, which means in the long run it's cost savings, because breaches identified in under 100 days have an estimated average total cost of $3.1 million. But if a breach was discovered after 100 days, the estimated cost increased by $1.1 million. So how are financial institutions currently using machine learning to reduce fraud? So we wanted to give you some examples of what's really in use today. So there are two approaches I'd like to touch on that are associated with machine learning for internal security. Now, a lot of the time these are built right into vendor security packages already, and both are quite effective. So first of all, organizations are analyzing user behavior, and this is referred to as user behavior analytics, or UBA. So this is the initial layer that we're seeing. Then additional behavior models for detecting anomalies within a network are added, and this is often referred to as the Network Behavior Anomaly Detection, or NBAD. So let's take a quick look at UBA. You'll find UBA implemented in a number of different types of platforms. So user behavior analytics examines the data points that are related to these three things here: the device profile, location awareness, and of course the user behavior part. So for example, let's say that a user normally logs into a specific device from a specific office location every day between 8 and 9 a.m. The user works in the marketing department, so generally he's accessing marketing materials and or marketing shares. But on Wednesday, the user logs in from his normal device at his regular location and at his normal time. However, at lunchtime, he logs off. And then an hour later, he logs back in through the company VPN, which is tied to an IP address in Indonesia. Now, in this type of case, we're going to know right away that there's no possible way that the user was able to travel from his home office in Denver to this Indonesia location. So this is going to be a red flag for the user behavior analytics, and what they can do is create a security event in need of further scrutiny, as this is really not a typical type of behavior from this user, and then we can add additional layers of authentication if need be. So now expanding on the user behavior is the network behavior anomaly detection, or the NBAD. Now this layer creates a baseline for normal network traffic utilizing data on volume, bandwidth, protocol usage, and then it alerts on any behaviors that deviate from that baseline. Now NBAD is an effective tool for detecting threats such as zero-day attacks, as well as encrypted traffic related to botnets. And I should also point out that this is used as supplemental security to standard perimeter defenses such as firewalls. So something as simple as a network device beaconing or calling out to a suspicious IP would be considered an abnormal behavior, and a security alert could be created and then an investigation opened. So while I can't speak for other organizations, I did want to provide specific examples of how threat intelligence created by machine learning is really leveraged to reduce risk. So Webroot leverages data into two specific solutions for financial institutions. So first, what we have here is the online banking security, and this is delivered through a small endpoint application. Now the data published from our machine learning is leveraged into three different layers of protection in this product itself. So first we have the ID shield, which locks down a browser to protect the user session from man-in-the-middle and man-in-the-browser type attacks. And then we have the real-time anti-phishing shield, and this blocks malware at the perimeter by detecting bad sites or bad URLs that may contain malicious content. And then the final layer that we add as part of this product is the anti-malware shield, and this blocks and removes malicious file-based executables based upon classification, and then also the behavior. So the second offering is our mobile banking security, and it's delivered via an SDK that's embedded inside of a customer application. So it provides silent security by scanning a device when the app is actually opened. So the initial health check scan reviews device information such as location, device ID, whether it's running in an emulator or it's rooted, and then it also takes a look at the apps that are installed, and then it assigns a risk score to that actual device. So the risk score can then be passed on to the organization prior to login. And what this does is allow the organization to make an informed decision on providing access to this device. Now, the amount of threat intelligence leveraged by these two products makes them very powerful security tools for fighting fraud and reducing risk for FI organizations. So as you can imagine, machine learning is a very complex process. So let's take a look at the process flow for collecting, analyzing, and publishing the reputation of a URL. So what we're seeing here is a model of the Webroot platform with the built-in machine learning. Now it contains a number of features that work together to analyze the data. So we have global inputs, historical databases, crawlers, and machine learning models built in. Now, in order to understand the flow better, let's follow a URL as it makes its way through the classification steps. So the URL first makes its way into the Webroot cloud platform. And when working at this scale, it's important to maintain excellent sources for collecting data to process. Now, these are our global inputs. Threat information from all of our consumer, enterprise, and technology partners flows back into the cloud's machine learning engine for analysis. And this is a never-ending loop of threat data that continues to make our models smarter and smarter. And here's a list of sources that Webroot uses for data collection, which feed into the cloud for analysis. Now, this is real-world data from real users, and it's coming in real time. So we can see spam traps, honey nets, victim machines, exploit honeypots. All these types of things are feeding this data right directly into our cloud for analysis. The first stop for the URL is the known classification database. So we see that here in blue. This contains a decade's worth of historical data, and it's in the neighborhood of 6 petabytes in size. So when a URL request arrives and it's determined to be a known URL, a response is provided for its classification or its risk level. And it's important to note, too, that a URL is not just analyzed once. URLs are analyzed on regular intervals, and then they're updated in this database just as often. So what if the URL is unknown? Unknown URLs will trigger an automated crawling process that takes it through a classification engine. This will place the URL into an appropriate category or categories depending. It's further enhanced by proprietary detectors for things like malicious files, phishing, and JavaScript, just to touch on a few of those. Another unique part of this process is that Webroot's platform will also indicate just how confident it is in its own determination. So low confidence scores trigger further evaluation by human analysts, and the URL is fed back into machine learning models. Contrary to that, high confidence scores are fed back into the known application database, and those are available for immediate use. So once the updated determination is made, the data is fed into our contextual database. Now this database maps the connections between URLs, IP addresses, files, and mobile applications. With these types of comparisons, we're able to identify bad actors that may on their own appear safe. So these relationships can impact the reputation score of the URL in a kind of a guilt by association model. Any URLs that are determined to be malicious then receive further scrutiny by triggering an additional patented deep crawling process to uncover additional threats. And just a side note on these, 91% of the URLs found with this method have never been seen before by our users. And if visited, our users at this point would now be protected from these. So the URL is now classified, and it's ready to be republished in the known URL database. So any URLs classified as malicious will now be blocked when accessed by any of our consumer, enterprise, or technology partners worldwide. So the entire process takes about 5 minutes, and the result is trusted threat intelligence. So just to summarize a bit, what we've seen is machine learning model based on speed and based on scale. So speed and scale are the lifeblood of machine learning. It's at the core of its value to the threat intelligence industry. So common approaches to machine learning involve, first of all, classifiers for speed, and second of all, characteristics, and models for scale. So classifiers do exactly that. They categorize objects into buckets such as IPs, web reputation, safe, adult, gambling. So the more classifiers in use, the more accurate the analysis. Now, scale is ramped up using object characteristics and highly trained models. So the more characteristics that can be gathered on an object, the more training that can be applied to those models. Now, these numbers here are examples of just how quickly threats can be identified, analyzed, and the results shared. So rather than creating machine models that are used by network behavior and for users internally, like we saw in some of those other examples, Webroot specializes in highly automated, massive scale machine learning. So we use advanced machine learning with multiple sources. We use hundreds of classification models covering different threat types and languages. We publish millions of updates on data objects every day. And we use 6th-generation machine learning, which includes, as we discussed, that deep learning core. And we do this all with really minimal human interaction. So now let's zoom out and have a look at how this data is processed through the entire Webroot threat intelligence platform. So on the left, the data sources collect and send threat intelligence to that cloud. And really, this is our gold nugget of data, because this is threat intelligence coming directly from our customers. And then once it enters into that cloud, it's captured, analyzed, classified, and published. So this is that machine learning portion that we just went through, and specifically for that URL. And then once we do have that published, we're not done yet. We will put that into that contextual database where we will compare and contrast that data. So we'll look at URLs, we'll look at IPs, and we'll create this 3D image of threat intelligence. And from that, we'll just leverage that then into different products and services that we provide to our customers. And eventually, that loops back into our system by the collection of the threat intelligence experienced by those customers. So we see that our cloud becomes smarter and smarter and smarter. And just to give you an idea of the scale that we're working with, the Webroot Cloud analyzes 500 billion data objects on a daily basis. So this scale of analysis, it really would not be possible without the power of machine learning. Now, machine learning has become a buzzword used by many, but to really vet products and services, it's important to ask the right questions. So we've come up with a few questions that you may want to ask when you're vetting services for machine learning. So first of all, what's the difference between artificial intelligence and machine learning? This will give you a big clue of whether this organization or the people you're speaking with know what they're talking about, because we've gone through those differences and you see that although they're related, they're certainly not the same thing. But you also want to know, do they have data scientists on staff? How many years of experience with machine learning? What are your data sources? All very good questions to ask. And here's a couple more. What type of machine learning are you using? What do you do in the machine learning process? How are your machine learning models updated? And really, it's the answers to these questions that's going to bring into focus the quality of the machine learning that you're discussing, and it's going to put you on that path to choosing a solution that's right for your organization. And I also wanted to throw in here, just kind of at the end, just to help you understand the different degrees of machine learning, a breakdown of how it's evolved. So this is the 6 generations, kind of as we see them listed. We started with the first generation, the Bayesian. This was a very simplistic, inaccurate model with weak discrimination capabilities, but we've since evolved through that into support vector machines, with maximum entropy discrimination, active learning models, and we've concluded to the point where we are now with deep learning. So we've kind of discussed we're on our way with the machine learning to move into that artificial intelligence realm. So that concludes the presentation for today. We can go ahead and take a look at some questions we may have at this point. So let me go to the questions to see where we have here. Let's see. Explain zero-day exploits. Okay, so the zero-day exploits that we mentioned, and machine learning, by the way, is very good at picking these up, because with the network anomaly analysis, we can see these types of things happening on the network, abnormal behavior of sorts. And really what that is a fraudster trying to access an operating system based upon a known unpatched security gap. So before a system is able to patch that through like an operating system or something like that, the fraudsters are trying to access with their software or their malware those gaps in the security system, normally to do something fraudulent internally there. So that's what that would be. I think we have a couple more complex here ones. Give me just a moment. So I have a couple more in-depth ones, but what I'm going to do is I'm going to address these separately from the webcast today. So with that, I'm going to go ahead and wrap things up for today, but I want to thank you for taking this time out of your day to join the webinar. It's always a privilege to be able to share knowledge on the things that affect us all, and I hope that you did find today's session somewhat informative. And in terms of security, we really must look at it not as a destination, but as a journey of continuous improvement, because there's always going to be things that we can do better. If you have additional questions or would like more information on anything that I've covered today, please feel free to contact me directly at the email address I provided there. And as I said, I will address some of the longer questions that came in directly, so I will respond to those directly and personally. So if you have anything, if there's nothing else for today, I guess I don't have anything else for today. We'll go ahead and sign off, and we will talk to you next time. So thanks for joining, and have a great afternoon, evening, and morning. Goodbye.